Welcome back to the Rooted in Resilience podcast. Today we are again joined by our friend Kathleen to yet again talk about the Minnesota Starvation Experiment. Why are these girls still talking about the Minnesota Starvation Experiment? Because it is so profound and it impacts so many things inside the body, and something that all three of us are really motivated to talk about is the importance of eating enough food as a baseline layer that you can check off. So to continue on discussing, there's a few more chapters left in the Minnesota Starvation Experiment. And so this is going to be episode 4 in the series. So we've already had the first episode was Kathleen's episode talking about all of the health challenges that she has overcome. Then we went into 3 episodes about the Minnesota Starvation Experiment, and then this is the 4th episode in that series, and we will link all of those below so that you guys can remain caught up. But Kathleen, do you want to just give another really brief outline of what the structure of the Minnesota Starvation Experiment, so that people can better understand why it's important that we pay attention to the results?
Right. So this was done in the 1940s, and the reason for it was they were more concerned about how do you refeed people, especially post-World War II with the famine from war, concentration camps, all of that stuff. And so they basically ran 30 men, pretty healthy, no major health issues or anything, college age. Slightly, some of them were a little bit older than college age, maybe more graduate school age. But they ran them through basically a 24-week starvation period where the average calories were about 1,570 calories per day. So not like water fasting, which a lot of people associate with starvation. And then after that, they had a recovery period where I believe it was for 12 weeks. And then from there, they had some men stay for even a longer recovery period. And at the beginning, the first part of the recovery period was controlled, and there were different groups, and each group received certain levels of additional calories compared to the other groups, and then they slowly built up from there. And then some people in each group received a vitamin supplement, and some other people received a protein supplement, an additional protein supplement, to see if they had any effects on refeeding. And this entire 2-volume, over 1,000-page, tome it basically describes everything that they see. So this is section 3 that we're going to talk about today. Section 3 is about the biochemistry. And the chapters in it are the nature of the biochemical problem, the basal metabolism, energy and protein requirements of normal persons. I think this is a really great chapter that we'll talk about. Total energy exchange and nitrogen balance, nitrogen metabolism, vitamins and vitamin metabolism, lipid metabolism, mineral metabolism, and carbohydrate metabolism. So basically includes a lot of the biochemistry. I also just want to preface this too. In the 1940s, and a lot of the research that they talk about from the 1920s and sometimes even before that, there was still a lot that wasn't necessarily known. And so, they were still trying to figure out, for example, all the B vitamins and which ones are essential, non-essential. They're still figuring out the essential amino acids. There's talk about the burrs and the idea of essential fatty acids. There's discussion about, back then they didn't necessarily understand, but they kind of thought that all the macros, so fatty acids, amino acids, and, carbohydrates, so glucose, etc., come into the citric acid cycle. But they were still not exactly sure how that happened and stuff. They had some, understanding of the Calorie cycle, which is how the liver basically deals with lactate. So a lot of these things that we talk about nowadays, they were still figuring out in the 40s. And there were a lot of assumptions and a lot of things, and a lot of, the individual enzymes weren't necessarily known, etc. And I would say even today, a lot of people believe that we completely understand metabolism, but we don't. We continually still find things, and we continually are still refining our understanding of the citric acid cycle, the electron transport chain. A lot of people believe, for example, with the electron transport chain, that it's just complex 1, 2, 3, 4, it's just in a series. But you can have super complexes of electron transport chains. So you can have multiple complex 3s, multiple complex 1s, etc., before you even get to complex 4, etc. So, I just want to say I think people believe that science is, quote, settled, when it's really not. And we're continually building upon things, continually refining things, even when it comes down to immunology, which we'll talk about in a second. Like when I took grad school immunology, the textbook was rewritten like every single year because there were major changes in our understanding every single year of what the immune system was doing. And this wasn't that, I took grad school immunology like in the late 2010s. So we're not even talking that long ago, right? So I think people need to kind of step back and understand that these are all models, they're all theories, we test them, we refine things, but that doesn't necessarily mean that this is the end all be all. So,
however, I will say, I feel like reading through the Minnesota Starvation Experiment, which we encourage everyone to do, it's easy to follow. It's easy to read. It is not a very scientific, like there's a difference between reading, like a story versus reading a technical research paper. It's not a technical research paper. It's a lot more of a literature review plus observations from the experiment. And so it is easy to follow. But I do like that it's observations because, like you said, it's not necessarily relying on a certain pathway or theory. It's just simply explaining what happened, what measurements they took, and how those measurements changed when they were eating enough calories versus not eating enough calories.
Yeah, they were basically like, we did this, we saw this change, this is what we think potentially could be happening, but we don't really know. But I appreciate that too, because like you said, it was more, they didn't really come into it with a belief of what something was going to happen. They just came into it as like, we don't know, so let's try it and let's see what happens, and we're just going to report the data, which obviously that doesn't happen as much nowadays. People want to confirm the bias of what they put the grant in for, and all of that stuff. So
that's something that Dr. Pete talked about a lot, is like he saw the shift in the science community, like back in this time frame, 1920s, 1930s, 1940s. Big pharma didn't really exist, and so there wasn't a ton of like funding by large corporations. And then he watched the shift in scientific research studies as they were kind of just more focused, like, all right, this is what we want you to show. So like coming in with the belief system.
Exactly.
But yeah.
Yeah, so there was a lot of questions last time about like what we were talking about, CO2 with Bohr-Haldane and the respiratory quotient, and we're going to talk more about the respiratory quotient today, so I just wanted to define it really fast. Basically, the respiratory quotient is the ratio of the carbon dioxide eliminated to the oxygen consumed. And so it's very hard to do this in like a person, but if you were to get someone to only metabolize lipids, so fatty acids, the respiratory quotient would be about 0.7. If you are only doing amino acids, it would be about 0.8, and then carbohydrates, it's 1. So the closer you are to that 1 of a respiratory quotient means that you're burning more carbohydrates and you are producing more CO2 because of that. So
yeah. So basically kind of just it gives an insight as to what type of fuel sources you are using.
Right.
And when one is not eating enough calories, it will probably, a body will rely more on fatty acids and protein.
Right.
So they will have a lower respiratory quotient.
Exactly.
And that is a way to assess metabolism.
Right.
Yeah. Yeah.
Yeah, because there's less CO2 produced for oxygen per oxygen consumed.
So, and obviously, from a P perspective, we think that CO2 is important because it is the main vasodilator of the body. I almost look at like CO2 kind of like California's energy grid. When California's just chugging along, we're good, we're fine. Like it's, the energy grid is enough to maintain the demand. But as soon as people get home from work and they all start turning on their air conditioners, etc., now there's like this huge demand very quickly. And so now you have to bring on other things online to maintain the energy grid. Well, to me, that's like nitric oxide, for example. So CO2 is what's maintaining this kind of like basal state. But then when you kind of need more of a demand past the basal state, that's when other things like nitric oxide, histamine, etc., kind of come online to help out.
So Dr. Pete was kind of one of the main individuals that discussed that carbon dioxide is just very important. And it's well established in the literature that the better you are at properly burning carbohydrates, so full oxidative phosphorylation, you're going to produce more CO2 as opposed to other energy substrates. And so going back to this theme of being a good carb burner has advantages because you produce more CO2 which changes the internal environment inside your body and thus changes function.
Exactly.
So
yeah, so I think starting off with the first chapter, so this section is over 300 pages, about 300 pages. So it's a very big section, right? So we'll slowly work our way through and we'll see where we get. But
yeah.
So starting off with chapter 16, the nature of the biochemical problems. This is kind of like a big overview of the next couple of chapters. But I think like right out the gate, a great quote that they said is the basic defect in starvation and undernutrition is chemical. The supply of the materials for chemical energy is just inadequate. And so again, this kind of goes back to what, Dr. Pete would talk about too, about, again, energy and structure being so intimately related that they basically go together. So the more chemical energy that you're able to provide, the more adequate that is, then that is basically a show of like you are no longer in undernutrition, starvation, malnutrition, etc. So.
Yeah. And to continue on that quote, so I have that quote written down too. So, quote, the supply of the materials for chemical energy is inadequate. This fact alters both the quantities of chemical reactants in the tissues of the body and the rates of their reactions. So, if someone understands that like the function of a tissue is the result of the number of chemical reactions occurring, if we don't give that tissue enough energy, those reactions are going to occur slower. So of course the function of that tissue is going to be downregulated. And so this beginning part of the chapter is really discussing how having enough energy coming in is a very important variable in controlling the function. Just talking Dr. Petey things.
Right.
Yeah.
I think we all very much appreciated his view on many things and his approach to metabolism and stuff. So I think that's why we reference him. But another thing that they didn't know about back then, because again, they were just looking at these things for the first time, was they didn't necessarily know, in a state of starvation, do you have like a major metabolic switch? Like, do you basically move from like the pentose phosphate pathway, TCA, ETC, beta oxidation, glycolysis, etc., to like something completely separate from that in the state of starvation? And they basically figured out, as will be apparent in subsequent sections and chapters, there are no indication that fundamentally new or different metabolic processes are involved either in the catabolism of undernutrition or the anabolism of rehabilitation. So basically, the same metabolic processes are happening in a catabolic state versus an anabolic state. It's just what's going on, basically, with these substrates, etc. The biochemical problems of starvation, then, are specific aspects of the problem of metabolism in general, and their full solution cannot precede the solution of the problems of ordinary or non-starvation metabolism. So they go hand in hand, is what they're basically saying.
I think before we dive in deeper, why should someone care? Because the mainstream messaging talks about the rate of living theory.
Right.
And a lot of people talk about how your metabolism, it should be like a slow burning candle.
Yeah.
The slower you can have that candle burn, the longer that you're going to live. And so a lot of people in like the longevity camps bring up the rate of living theory. And under that belief system, they believe that a slower metabolism is good for longevity. You'll live longer if you have a slow metabolic rate. And here, three girls are talking about, no, you want a fast metabolic rate, which is like exact opposite of what even Harvard like researchers are saying right now.
Yeah.
So why should someone care, and why do you not believe that the rate of living theory, which is a slower metabolic rate, is better for longevity?
Yeah, so this goes back to the Hayflick limit, and basically that was found in, I think, like the 1960s, and it basically said that in cell culture, I think it was a human fetal cell. I don't remember the actual cell that they put in the cell culture, but it basically was shown to divide 40 to 60 times. And so they say that the Hayflick limit is about 60 times that cells in your body can divide. And so then this would go to the rate of living theory, right? Because it's like, if I can only have my cells divide 60 times, well, that's going to be a problem, right? I mean, some cells, their half-lives are years or even like our entire lifetime. And so we're never going to run up against that limit, so, But other cells, like the enterocytes, for example, they're, order of days, right? Like the entire GI pretty much turns over about every 3 days to a week. And so now you start to have issues where you're, okay, maybe we're going to start to run up against, these limits, right?
Three times 60. That's how many days I can live.
Yeah, and there are stem cells and other things that are like producing more cells and everything. But I think the big issue with the rate of living theory and the Hayflick limit is that you're looking at singular cells in a cell culture. You're not looking at the field. You're not looking at the body as a whole. So while I'm not going to say that I don't think that there's ever like potentially any limit, I don't think it's 40 to 60 times. I think it is way more than that. I also think that, like Dr. P, for example, would talk about like the idea of stem cells and really how like any cell could technically be a stem cell. And so I just don't think it applies, right? Because again, you're talking about something in a petri dish versus in vivo. And I do believe that in a more of a field concept. And so, yeah, I mean, there's going to be people that disagree with me, and that's fine. But like, I would rather create more energy for more structure in order to continue to create more energy for more structure, so it becomes like a positive feedback loop versus this kind of like, don't want to do that. And I also want to say too, like, and we'll get to this eventually, but there's a really great quote in here where not too long ago, so like in the 40s, in the 50s too, 3,000 calories a day. You know how everything is based off of 2,000 calories a day now, like on the nutrition facts and stuff? 3,000 calories a day is what things used to be based off of. So like, why did we just all of a sudden decide to drop off 1,000 calories? And I also want to say too, like, people are talking about downregulating their metabolism because of this rate of living theory. But like, if 3,000 calories is normal, and that's like a normal rate of your metabolism, and that's like not upregulated, like, we're just going back to normal. I think that's the biggest thing I want to like keep pushing forward, is that like normal calories for women back not too long ago was like 2,500 to 3,500 a day, depending upon how. So 2,500 on the low end, like if you're like really sedentary, older, etc. 3,500 on the higher end if you are in the cold, not so sedentary, breastfeeding, pregnancy, all of that stuff, and then obviously more for men.
That point right there. So like, what we used to be able to, the normal was eating more calories and maintaining a smaller body frame than what is happening today. That is an example of rate of living theory not working in practice, because earlier in the 1900s, they were eating more calories, less rates of chronic disease, versus today, we actually see a decline in our life expectancy. We have more chronic disease. Our metabolic rates are lower, and we're not able to consume as many calories. Like, personally, I really like to eat. And so a benefit of having a higher metabolism is you can eat more food while maintaining your weight. Like, who doesn't want to do that? I don't want to be eating 1,600, 1,500 calories a day. Like, that's one benefit. But like you said, you can also have better structures, better function, and, not have this wide range of severe food intolerances and all of that. It's just living a better life.
Well, and people are so concerned about supplementing nowadays. And I just go back to when you eat enough, especially if it's, for the most part, micronutrient dense foods, like hitting the RDAs and the DVs become like very easy, so you don't have to worry about supplementing things, and then you start playing supplement whack-a-mole because the supplement is like so overdosed that it's now pushing pressure on these enzyme pathways, and then you cause like a B2 deficiency, and then you start to get like signs of B2 deficiency, or whatever it is. So I think that there is a time and place for supplementation, but I think it should always be on the backbone of sufficient food, making sure you're digesting that food, etc. So
a homework assignment for everyone listening is to just go on Chronometer on a desktop, insert in like 1,500 calories worth of food, and then insert in 2,500 calories worth of food, and look at how much the vitamin and mineral content changes. Like, you easily hit all your RDAs.
Well, I think something that people like to argue though too is that if they focus on nutrient dense foods, they don't have to eat as much because they might be hitting their vitamins and minerals already. But I think they're losing sight of the fact that we still need energy.
Yeah, so we'll get into this in like the nitrogen protein chapters, but so Okay, so when you eat less calories, most people will go towards proteins because per calorie per 100 gram, for example, proteins will have more micronutrients, and then they have more zinc, more copper,
B vitamins.
vitamins, yeah, all of that stuff, more fat soluble vitamins. So it makes sense why people do this, and they actually talk about that. I have a quote something about this like later on, but and I would agree to an extent that if someone is that low calorie, they probably do need to have a higher percentage of their diet coming from protein to make sure that they're getting enough micronutrients. However, though, this then brings up nitrogen balance, because when you are that low calorie, and there's a great quote in here that we will have coming up soon, but when you are that low calorie, even if you eat more protein, they saw then. So all I'm doing is reporting off of what they saw, right? I don't know about new research. I'm just reporting what they say. They saw then that increasing protein does not lead to better nitrogen balance. So, and nitrogen balance, the reason why that is important is because it's a marker of anabolism versus catabolism in the body, right?
Wait, pause.
Go ahead.
What is nitrogen balance?
Yeah, so nitrogen balance is basically the amount of nitrogen coming in, so nitrogen intake minus nitrogen loss. And so in a anabolic state, you are overall in a positive nitrogen balance. Like at certain points during the day and stuff, you might see a little bit of loss, but you are overall in a positive nitrogen balance. In a catabolic state, you are in a negative nitrogen balance because you are losing more nitrogen. And nitrogen, amino acids are called amino acids because they have a nitrogen in them, where fatty acids and carbohydrates don't have a nitrogen in them. That's what makes them different, right? And this is why things like the urea cycle become incredibly important, because when that nitrogen is metabolized, it most of the time becomes ammonia, and you need to get rid of that ammonia because it's highly toxic to the body, and create urea, which is then what we urinate out, right? So back to what I was saying, in a low calorie state, they did not see improved nitrogen balance, so an anabolic state, which is what we want to be in, right? When they increased protein. What they did see, though, is that you can be at low levels of protein intake, but if you increase carbohydrates to a certain extent, your nitrogen balance at least goes to, neutral, and if not, becoming anabolic. So I think that's like, so people that are leveraging protein in order to, be on low calories and stuff, I think to an extent, again, that is fine because you need those micronutrients, but it needs to be under the guise of sufficient carbohydrates. And they did not see this with fatty acids. That's why I'm focusing on carbohydrates right now. So,
real quick, nitrogen balance can kind of give you an insight as to protein balance in the body.
Yeah,
right?
Yeah, they again, this is in the nitrogen chapters, but they even say that it's better for people to follow their nitrogen balance versus their weight loss, like their scale weight loss, because there's so much, I mean, we've talked about this before, there's so much that goes into the scale weight changes with like fluid changes, and, are you losing muscle tissue? Are you losing fat tissue? Are you losing a little bit from the skeleton? Because we don't see much loss in the skeleton, like all of that stuff. So they would rather, or they said that it makes more sense for people to focus on nitrogen balance than it really does for people to focus on scale weight. Obviously, though, it's a little bit harder to, track nitrogen balance versus tracking scale weight. And so that's why we use it.
Because I think people think that like once you have muscle, it just is staying there and then you just add more muscle. But like protein levels in the body is dynamic every single day. So your body's constantly breaking it down, rebuilding, breaking it down, rebuilding. And so as Kathleen was saying, the nitrogen balance can give you an insight as to whether you are in a general positive protein, so you're building protein, or negative, you're losing more protein.
Right.
And obviously we don't want to lose protein, which means that we're losing muscle tissue, whether that's active or involuntary muscle tissue. And I think that would be a really cool thing for people to track as they are trying to lose weight. Be like, okay, you can track your body weight scale, but also track your nitrogen balance to see if you are maintaining muscle or losing muscle.
Yeah. Yeah. The only thing is that for nitrogen balance, I think you need a lab and stuff in order to run it. But if you can find a lab and track it every so often, I think that would be great.
How, so you would just, is it Pee?
It's in in your urine.
So you would just send in a bunch of pee tests.
Yeah. 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 Well, and also you were talking about muscle. Like, obviously, we don't want to lose our muscle, but I mean, like we talked about, I think last time, the amount of weight loss at the organs too, especially the GI loss.
Yeah.
So we're not only losing muscle tissue, which so many of us are trying so hard to put on and like maintain and all that stuff, but then you're also talking about like internal organ tissue and stuff, and then you start to wonder why things are not operating as they should be, right?
Yeah. And then, so something that they bring up again, Kathleen brought up in the beginning, during this time they were trying to figure things out. And it's very clear that when you're in this semi-starvation state, your metabolism drops. So that is like very easily recorded. When you're chronically under eating, there is no reason why your body would maintain a high metabolism. That would be like a death sentence. It of course has to downregulate. And one of the questions that they kept asking was, what is the reason for that down regulation in metabolism? And one thing that they bring up is potentially the loss of tissue, because when you lose tissue, then the number of chemical reactions, chemical rates is happening or is less.
Right.
So that would be a reason why. And technically, if you were to lose weight and lose largely fat mass, you shouldn't see a huge reduction in metabolism.
Right.
Right? Yeah.
Right. Assuming that it depends on the initial starting point, right? It's always going to depend on that. There's always nuance here, but talking about what you just said, a great quote is, in severe undernutrition, as in the Minnesota Starvation Experiment, the total basal metabolism of the body frequently falls by 40%, and there are no signs of impairment of brain function. Metabolism of all the rest of the body must fall not by 40%, but by almost 50%. This would indicate a very considerable decline in the metabolic rate of the other active tissues and would substantially alter the analysis of metabolic adjustment. So again, we talked about how, the brain stem, spinal cord, etc., they barely lose weight except for until you get to kind of end stage starvation. And then in end stage starvation, you start to see irreversible lesions in the brain, which like threw up like some red flags because of things that we talk about with like plaques in the brain and stuff. And so, I wonder. But especially because people are saying that like Alzheimer's is like type 3 diabetes of the brain and stuff now. So yeah, I just wonder, right? Throws up red flags when I read stuff like that. But so it's saying because the brain is spared, that means that the body is even more downregulated than the brain. So instead of 40%, it's almost by 50%.
Yeah. Yeah. And they bring up like the mechanisms of this BMR reduction. So like, it's easy to just say, when you eat less, your metabolism declines, but like, why? Like,
right.
Why is it declining? And a few things they bring up is, like I said, the reduction in the tissue mass, reduction in the cardiac work, so the amount of output of the heart, the reduction in tension or tone in your voluntary muscle goes down.
Yeah.
You see a decrease in body temperature, which leads to a decline in the rate of all chemical reactions, because chemical reactions, they occur optimally at a certain temperature, and when temperature is declined, the rates of those reactions goes down.
That's why, sorry to interrupt really fast, that's why this like normalization of declining body temperatures is not okay, because our enzymes, especially in our body, are meant to work closer to this like 98.6 Fahrenheit, but in our brains are even warmer than our bodies. And so if that's starting to drop, well, you can start to see how this causes like negative knock-on effects.
Yeah. Well, maybe so. It around this time, like you said, the average calorie intake was like 2,500 to 3,500 for women. Body temperatures were 98.6 degrees Fahrenheit. There's been a well-documented, like just literally search in Google, anyone listening, you can find the paper that outlines and shows a decline of about 1 degree Fahrenheit in body temperature. Well, now we've also seen like a recommendation of eating less calories. So this is very well documented that it's happening in real time to the American population and maybe other populations worldwide. But
it's just funny or not funny, but if you think about that timeline, you wonder like what came first, the recommendation to eat less and then the lowered body temperature, or we're doing things like the foods we're eating or the high stress life or whatever is lowering the metabolism. And so we're having to eat less and less and less. So
that was, Kathleen, that was actually a really big question that we got from our previous episodes is like why we're seeing this.
Yeah.
It's like the chicken or the egg, though.
Yeah. I don't know. All I can say is that anecdotally from working with people, when you restore the energy, you start to restore these other things like body temperature, like psychology, the physiology, like all of this stuff. So I agree. Like I think the problem should be investigated more, especially like is it coming from our increase in PUFA intake, for example, or the decrease in an actual refined sugar intake, slight decrease in refined sugar intake. Or is it coming from, like you said, the stress, or is it coming from some environmental toxin like brake pad dust, for example?
Plastics.
Microplastics. Like I agree, but at the end of the day, like I am very much of the positive opinion that you provide sufficient energy to the system, to the body. The cells structure themselves appropriately. They push things out, assuming your excretion, elimination, detox pathways are open and stuff. You can get these things out. So that's how I approach things versus kind of like this almost negative view of like there's nothing I can do. The environment's out to get me, like stuff like that. So that's how I do. Maybe I'm too optimistic in that, but it seems
that's the only way to view all of this, though, because chemtrails, like there's all this stuff in the air now, and you go to people's like protocol pages and like the list of supplements that they have to like bind and remove all of these things. It's overwhelming and it's scary.
Right.
And that leads to more fear, mental stress, which then furthers metabolism and like interferes with your ability to enjoy life. And so what Kathleen is saying is like when you restore your metabolism and ability to properly produce energy, the function of your detox pathways improves. And so you can get rid of certain things that aren't belonged to be there. Of course, you don't need to go chug warm water out of plastic water bottles or like down vegetable oils.
Yeah.
Yeah.
Well, and also like just going back to like the liver, for example, phase 1, phase 2 liver detox requires a lot of stuff. Like all the B vitamin, glucuronidation. Everyone's all concerned about glucuronidation nowadays because of estrogens, etc., which I understand. Glucuronidation needs a lot of glucose and then, a lot of supporting B vitamins and stuff for it. There's sulfation, there's taurination, there's glycination, like methylation comes into this, like everything comes into this and requires a lot of ATP. So your just basic energy state. And then it requires a lot of micros in order to your cofactors for the enzymes and stuff. So, so I just go back to, people are all concerned about the liver or about the kidney, and I think rightfully so, right? Like we're seeing huge issues with them, but it's like why are we not just supporting them?
Because didn't we show last time we discussed how the liver shrunk by 40%? So like of course it's not going to function best. Yeah,
and they saw the fatty infiltration of it, and what do we see nowadays? What did they just redesignate it as? It was like NAFLD, now it's MAFLD, like metabolic. It's like basically NAFLD, but now they call it metabolic instead of non-alcoholic fatty liver disease. So maybe it's MFLD now. So back to the brain. Another great quote that I pulled was, and again, this is going to highlight how kind of new this understanding was. So this is from 1941. Since the brain ordinarily derives all its energy from carbohydrate metabolism, even in starvation ketosis, the conclusion is forced that 1, the brain's use of carbohydrate is reduced in starvation, or 2, the respiratory quotient of the rest of the body is much lower than indicated by the total respiratory quotient, or 3, the estimates of the large proportion of the total basal metabolism in man accounted for by the brain are in error. So they're basically saying either the brain can use other things other than glucose, and its metabolism can drop, but they basically argue that we don't think that's possible. Because of what we see with like the weight changes.
Well, and there has been recent research that has like shown that the brain is literally incapable of using fatty acids for fuel because it's way too slow.
Exactly.
Yeah.
So 3 is pretty much out the window. So then you have 1 that the brain would use less carbohydrates. We just talked about that. That's out the window. So basically you're left with 2. So again, this goes back to the body is taking the brunt of this. So the respiratory quotient of the rest of the body is much lower. So like you have the total respiratory quotient, again, the carbon dioxide compared to the oxygen used. But that's that's accounting for the brain too. So really, if you're just accounting at the body, that's going to be even lower. And that is problematic. And so then you get into discussions of like, okay, well, if we're not in a like true semi-starvation state, which I think is kind of a fine line for a lot of people nowadays, do you want to create the situation where the respiratory quotient is lower, closer to that 0.7, point? And I think it's a fair conversation to have, and I'm not so sure you want to be honest. But that,
I didn't write this down. Did they give numbers of the respiratory quotient for the control, which is the start of the experiment before they did any semi-starvation, and then the respiratory quotient at the end of the semi-starvation?
They do talk about it. I did write it down. I'd have to find.
It definitely declined.
Yeah, they definitely saw a major decline, closer, I think, to the higher 0.7s, but I'll have to find the quote, and when we get there, we'll.
And so again, that just shows like the energy pathways are changing as we are in this semi-starvation state, and that has implications.
Right.
Less carbon dioxide produced is one thing.
Yeah.
And with, like you said, I think that the fact that the brain is so is so important for the human body that it preserves its normal metabolism, and then the rest of the body just like takes the hit. So any reduction in respiratory quotient is like magnified for the rest of the body, because the average of those two, the brain and the body, is lower. And if the brain stays the same, then the body's got to go a lot lower.
Yeah. And this is probably going to ruffle some feathers right here, but I'm just going to, there's a lot of quotes in here that will ruffle feathers nowadays. But it is generally agreed at present that fats, except for minute amounts of certain fatty acids, so this is the essential fatty acids, right, are not essential in ordinary nutrition. Since fats are readily synthesized in the body from carbohydrates, this is understandable, and there might seem to be an obvious justification for rejecting claims from famine areas that their populations suffer from fat deficiency, but this may be an oversimplification. So again, nowadays you hear the argument that carbohydrates are not essential because we can make them from amino acids and fatty acids from gluconeogenesis. But back then, they viewed fatty acids as not essential because they can be made from carbohydrates. And that carbohydrates are so essential because of the brain, etc., that you would want to leverage them over fatty acids.
Yeah, people don't like to talk about this. But the reason people say the words essential fatty acids is because the body doesn't produce those.
Right.
But the body does produce other fats. And Brad Marshall, Fire in a Bottle, talks a lot about this. Populations with the highest recorded metabolic rates were very high starch eaters that didn't consume much fat. And as a result, internally, their body produced a lot of fat. And that fat is saturated fat. The body is not going to produce PUFAs inside of us. I think that that's for a reason. The body knows that those are kind of like toxins. And so when you do, none of us are saying to eat a zero fat diet. None of us are saying that. But when your body does produce fats inside of you, it produces saturated fats, which is really fascinating. And that improves metabolic rate in the long run.
Exactly. Yeah.
I guess the reason I like to talk about these things is because I think it really challenges people's belief systems of like, carbs are not essential, so I don't need to eat them. Well, all right, we can just throw this right back at you. Fat's not essential, so we don't need to eat it. But is that a good idea? No, but it's so, like you said, it's so interesting, the difference in the narratives between the two time periods.
Well, and also, okay, I recognize that the 40s are somewhat a long time ago, but to me, like, I really don't think of them as being that long ago, And so the fact that, like, we've gone from the 40s saying that fats are not essential, except for a small amount of of the essential fatty acids, to now carbohydrates are not essential. It's just funny to me how we swing back and forth between these things. So I think that probably means we need to meet somewhere around the middle, and that's
balance.
That's probably the answer. So, and then they talk about how in the body there seems to be a level of deposit fat, which is like a useful energy reserve, and then essential fats for things like cellular architecture, vital machinery, etc. And then same thing in terms of the proteins in the body too. There seems to be a level of like amino acids in the body that can be used for things like energy and stuff and not start to cause like a big hit on the body. But then you get to the point where there's just the amino acids more for like structure, because pretty much proteins make up all of our structure. So I found that to be interesting.
Yeah.
And so they basically say, the preferential use of fat as fuel is imperative in starvation, like that, fat is necessary, right? If we didn't have fat, we would die. So, I don't think any of us are saying that we shouldn't have fat tissue. And I don't think any of us are saying that we shouldn't consume fat. But, I also think carbohydrates are important as well. And, they say that the glycogen reserves are quickly reduced in severe undernutrition. They're never totally depleted, because people will talk about how you do see. So at first, when you like start to fast, for example, like do a water fast, you do see the like rapid glycogen loss in the liver and the muscles. But then you do see some of it get refilled again, but it's very low compared to the amount that they originally started with. And that's probably, again, just to maintain that glycogen reserve for the brain in like periods of like extreme stress, or like when you're like, okay, we got to get the brain working really quickly.
And again, glycogen is stored carbohydrates. And for every 1 gram of glycogen, your body holds on to 3 grams of water. And so, you see people doing these fasts and keto and low carb, and they see a rapid loss in body weight sometimes. But again, what is lost? And I think that that's one of the biggest things that I've taken away from the Minnesota Starvation Experiments is we need to be paying attention to more than just the scale weight. And if there's simple ways that we can assess, nitrogen balance or water weight and see what we're actually losing, because 10 months down the line, if you just keep at that and you're losing muscle tissue and that's not going to lead to a good functioning body. And so I think that that's kind of been one of my biggest takeaways so far, is how much tissue they lost during this semi-starvation state.
Exactly. Yeah. And, talking about like basal metabolism and stuff. So this is specifically about the men in the MSC. So at the beginning of the MSC, their basal metabolism used about 1,570 calories per day. And then after the 24 weeks of the semi-starvation, the basal energy use had fallen to an average of about 958 calories per day. So they say if the basal nitrogen requirements fell in proportion, its value would then have been 18.3 grams of protein daily, a protein intake which would have just met minimum requirements before starvation, would after semi-starvation provide an excess of 11.7 grams of protein. This is why I think when they started refeeding, the protein supplement had little effect, because their basal metabolism had dropped so much that now they were technically eating excess protein compared to what their body truly needed in order to maintain nitrogen balance.
Yeah. And that was a 40% reduction in basal metabolic rate, which is like close to 600 calories per day. So that means like the person could just lay on their bed and eat 600 less calories and maintain their weight, versus someone else laying on their bed all day and eat 600 more calories. Like that is a huge reduction in basal metabolic rate. And that's just from 12 weeks.
24 weeks.
24 weeks.
Yeah.
Which is what, 6 months?
Yeah.
And think of how many people are just in this semi-starvation state for years.
Yeah. Yeah. And people will say, okay, but I didn't drop that much. But like, at the same time, you may not have thought that you dropped that much, because you're assuming that your maintenance calories are like 1,800 calories a day. But like, what if your maintenance calories are actually 2,500 calories a day? And then even if you're in this kind of like subclinical like calorie deficit, I think the time. So like, say you're only like 300 calories low, but like you've been doing this for 30 years. Well, that's going to have, I think, a big impact as well. So I think that you have the acute effect and the chronic effect that needs to be considered.
Yeah.
They talk about like different animal experiments and stuff, and they basically say, so in a couple of the animal experiments, they found that additional like methionine and stuff, so one of the amino acids, was able to
wait, say that again.
Methionine.
Yeah, I know.
Are we all saying? Am I saying it wrong? I say methionine.
I know people say methionine. I guess it's probably methionine. I always say methionine.
I like Methionine better. Say it
It's
again.
because
Say it one more time.
methionine. It's because when I was starting to learn about these things, I learned from reading, and so I did the whole like, okay, let me sound out this word and let me see.
I like it. I like it.
It's
I
funny
like it
because-
better.
I guess she stuck with it.
yeah, it's funny because when Harrison, he's like really getting into reading and stuff now, and he'll do a very similar thing where he's like, sounding out the words and stuff, and he'll say, "Oh, this is this." I'm like, yeah, I know it looks like that, and it probably sounds like that to you, but this is actually how we say that. So English is an interesting thing. But okay, so methionine, they found that methionine was helpful for like nitrogen balance in some of the animals and stuff, but they did not see the same effect in man. And so they just say, yeah, they just put up a warning again of like, and we all know this, but like, just because you see something in animal studies doesn't necessarily mean it's going to apply to human studies. And so you do, like, yes, it is, a lot of things are conserved, and so you can get a lot of information from animal studies, but then you need to go verify it in humans and see if it has the same effect. But they did posit that maybe there are some amino acids that could potentially help lower nitrogen loss. And something that we'll talk more about when we get to the nitrogen chapter is that, and this is a consideration, they found that people who were kind of on a low carbohydrate, kind of keto diet, but also maybe a little bit more protein than a lot of people in that do a keto diet uses. When they then go into starvation conditions, there isn't as much of a hit to their nitrogen balance versus if they were predominantly eating carbohydrates or having a higher proportion of carbohydrates and then going into starvation, what that effect on their nitrogen balance is. And I find that interesting, right? Because people will say this all the time that like before you do like a fasting protocol, you should do ketosis first because it's easier to get into the fasting protocol. And it's interesting, right? But that's not something I want to do. But maybe for people that need to do it for some reason, that is a consideration. I'm trying to be as like, I have my own biases, of course, and I'm trying to be as objective as possible to like what they present and like share it with everyone because, again, maybe there is some situation where you would need to go into a fasting protocol and maybe this would make it a little bit more tolerable. However, they also talk about the mineral status, especially the electrolyte status, which we'll get there eventually. And that leads to really bad electrolyte status, which I think you see nowadays with everyone being like, we can't maintain our electrolytes on low carb, etc. So
yeah, our ancestors did not walk around with electrolyte packets all day long. Which is like fine. If you like to use electrolyte packets and you want to use them, that's great. But this was not something that was regularly used during this time because they ate enough food and they ate carbohydrates.
Exactly. So that's, I think, everything from chapter 16 that I had.
Yeah.
So we can move to chapter 17 now if you want.
Which one is 17? I didn't write down the chapters.
Basal metabolism. So talking about like the BMR differences between sex, age, climate, and race.
I think like, so when you bring up metabolism, I think like many people are going to say, oh, your metabolism slows as you age. Oh, that person was blessed with a fast metabolism so they can stay lean. I have a bad metabolism, so I've got to always watch my food intake. And so there's such like this like genetic thought around metabolism that people believe that it's out of their control sometimes. And I think that that's something that this chapter kind of highlighted. Yes, there are some differences, of course, but the results of the Minnesota Starvation Experiment show you can change your metabolism, and also many of the other studies that they brought, because what they saw with the Minnesota Starvation Experiment, their metabolism dropped by like 40%, but then a rapid rise in their basal metabolic rate during the recovery phase when they were eating more calories. And they speculated, fat was being laid down, but also active tissue was being restored. So, liver tissue shrunk by 50%. When you restore your liver tissue, of course, your metabolic rate's going to rise. So again, going back to this like hopeful and positive outlook, like there are things one can do to restore metabolic rate. It's not like we're doomed.
Exactly. Yeah, I think that's the biggest thing to take away from this chapter is that, like, for example, they see a higher BMR in people that are in cold weather. And to be honest, like, I kind of wonder, is this the reason that there's been such a push for like cold thermogenesis? You know?
Yeah. Yeah.
I mean, maybe because they're like, maybe we're trying to, start to stimulate things by using the cold. I mean, it's possible, but then at the same time, you need to then support that stimulus by providing yourself with sufficient fuel for it, right? Um, and yeah, so they do see, differences in men versus women, of course, then and adults versus children. Um, so, yeah, so there is a difference, but I don't think it's as much of a difference as people think. And like you said, you can do things about it. I think that again, that's a very positive thing, right? Like you're not doomed to whatever your parents gave you.
Yeah.
Like,
Well, it's remember that type of thinking that like, oh, you're doomed with those genetics. That's very much bred from pharmaceutical companies because they
Mhm.
want you to think it's your genes.
Right.
As a result, take this prescription because there's nothing you can do about it because it's genetic. You can't change that.
Well, especially when most of the pharmaceuticals on the market right now, what do? They block things. They're antagonists. So you're not actually dealing with the problem. You're not, you have a buildup of something, or you have, something going on. Like you're not actually dealing with that buildup. You're just blocking the signal from your body. So like I don't know. It's just a weird thing to me. And again, I think that there is a time and place for pharmaceuticals sometimes. Like yes, in an acute situation, certain pharmaceuticals can save someone's life, but it should always be under the guise of like, okay, now what are we doing in order to come off of this? What are we doing to make sure that we're supporting the body? We're actually dealing with whatever this beta blocker or calcium channel blocker or whatever is doing. So to me, if you're not having a conversation with your doctor of like, okay, what's the plan for me to get off of this? I think that's a problem, especially when none of these pharmaceuticals have ever been tested together, and most people are in a polypharmacy situation. And you just wonder about like the iatrogenic deaths and all of that stuff. So
And the health of individuals in the 40s and the 50s was better than it is today. And like the pharmaceutical industry really wasn't this powerhouse monstrosity that it
yeah,
is today.
I also just want to push back a little bit on like people think that our ancestors never had any issues, but like I'm reading the Tales of Genji, which is like one of the oldest books known, and like they're talking about women having nausea and like all these issues in pregnancy and like having major issues with childbirth and stuff. And so I think that there is a fallacy basically of like we believe that things are so much worse now than they were then. And yes, I do believe that overall things have accelerated, and it does seem like there's way more numbers and stuff now. Of course, I'm not going to say that that's not happening, but I think that some of these things were also happening then, and they were not as rare as a lot of people like to claim that they were. So
All right, what was the next chapter after?
yeah, I think that was like the big, again, like you said, the work output of the heart per minute is reduced by about 50%. And so all these people that have like kind of like POTS type issues, dysautonomia type issues, like again, red flags kind of come up of like, okay, you're sitting down and you're okay, but you get up to go move and all of a sudden your like heartbeat is like going through the roof and you feel like you can't catch your breath and all of that stuff. So that was like the last quote from that one. The next one is chapter 18. So this is energy and protein requirements of normal persons. So this is, I think this was a pretty good quote. The basal standard of energy expenditure per day for an average 70 kilogram man or woman engaged in sedentary work was established at 2,400 calories. The assumption of sex equality is certainly not justifiable. It was concluded that to this basic caloric requirement, 35, 75, 150, and 300 calories per hour should be added for light, moderate, hard, and very hard work. So that goes up, real quick. Yeah, and then this is where the 3,000 came in. This scale provided 3,000 calories for 8 hours of moderate work, which is identical with that recommended by various other authors or committees. The main difference lies in the fact that in the other recommendations, 3,000 calories is taken as the basic unit. So again, 3,000 was taken as like, this is the standard we base everything off of. So again, I kind of wonder like, how did we get from 3,000 to 2,000? Like where did that happen? How was that choice made? All of that stuff,
Yeah. Maybe the start of the U.S. health dietary guidelines.
Yeah, let's say it's probably documented somewhere.
Yeah.
Well, it's interesting too, though, because like not too long ago, the focus of like the USDA, et cetera, was about people getting enough calories and enough micronutrients, especially because like there's like a huge pellagra issue. So that's a vitamin B3 deficiency in our country, especially in the South. And there was major steps taken to make sure that people were getting enough vitamin B3 because they had pellagra, right? And so it's just very interesting to me from like the country that had major issues with some of these deficiencies and stuff, for people nowadays to believe that there's no possible way that the US and Europe, etc., could have deficiencies now. It's just weird, I don't really understand it, especially because of the history,
And like, okay, 1,000 calories per day is a huge difference. Like, it would be a different story if it was like 50 calories per day.
Right.
Going from recommending someone to eat 3,000 calories a day down to 2,000 calories, that's a huge jump in a relatively short period of time.
Exactly.
Yeah.
Yeah, and so they said that the total calories supplied by protein and the very high caloric diets is about the same. So basically, every diet back during this time frame supplied about 10 to 14% of your calories as protein. So again, like it's a conversation of, do we really need as much protein as a lot of people are saying nowadays, especially in context of sufficient calories. And like I have another quote in here of like, they were talking about for a man that was like moving a lot, had a very hard job and stuff. He was eating, they said that he had to eat like 116 grams of protein per day, but they thought that might be actually too much for him. And like
now it's like 160 to 250 grams of protein. Yeah.
Exactly. Yeah.
I think that the protein obsession could have almost been fueled by this big change in like style of bodybuilding. So this one guy on Instagram, I think his name is Chris or something, like, no, not Chris. I forgot his name. He talks about bodybuilding era before steroids, bodybuilding era after steroids. And when you put steroids into the equation, the body is able to put on so much more tissue mass because recovery is sped up so much. And so, of course, you have the potential to be in an anabolic state more often. But in our normal humans able to have those rates of muscle growth? No. And so protein powder didn't exist back in the 1940s. Like, that wasn't like a thing you could really go and buy a bunch of protein powder. So like, has this huge increase in protein powder kind of popularized that as well. And I think one of the biggest things I've learned from Kathleen is like protein, like ground beef, eggs, milk, cheese, all very good because they're so micronutrient dense. They're really good tasting. But does your protein need really scale up as you eat more calories? No. And that's what they kind of talk about in this chapter a little bit.
Especially because, yes, we're constantly cycling our proteins, our muscle mass, our organ tissue, all of that stuff. But, the amount of muscle that like a natty can put on in, a day is very little. Like, we're talking like grams, like maybe tens of grams. Like, we're not talking about a lot here. And so, so you can see, obviously, like you said, when it comes to things like anabolics and stuff, that changes. But you still don't need as much as I think people think. Like this, there's like two great quotes that I pulled from this chapter. But so the first one, in general, at diets of 3,000 calories or more, nitrogen equilibrium can be maintained at an intake of 40 grams of protein or less. All diets below 3,000 calories, nitrogen balance is harder to obtain even at higher nitrogen intakes. So again, this is like that 3,000 calorie mark too, because they literally just said to maintain nitrogen balance, even at higher protein intakes, less than 3,000, becomes very difficult. So like, why did we drop below 3,000? But so, and 40 grams of protein at 3,000 calories, you get that like if you eat sweet potatoes or potatoes, like or sourdough bread, you get more than that if you eat those sources, right? So, and again, that doesn't mean I'm saying that we shouldn't be having, animal protein and stuff. I think that we should. I think it's important, but I think this calls into question, like, how much do you actually need? And then the other quote is, the authors concluded that the National Research Council recommendations of 70 grams of protein per day are overly generous and might be reduced to 50 grams, still leaving an ample margin of safety. Again, under sufficient calories, though.
Yeah. If someone were to eat 1,200 calories and 50 grams of protein, they would struggle.
But at the same time, though, like I said, there's that one quote that we talked about how you don't get nitrogen balance. So when you're low calories, you don't get nitrogen balance unless you bring your carbohydrates up too. So yes, while I do think the ratio will be more protein than what they're talking about at 3,000 calories, I don't think it's as much as people want it to be, because they need that carbohydrate in there to keep the nitrogen balance. And I think, I think if people were, maybe measuring their nitrogen balance a little bit more, they would start to see some of these effects.
Yeah.
Well, while we're talking about this, can you explain what some of the negative effects people might see?
Yeah, so I think like a perfect one is you're eating all the protein, you're working out hard, you're like not crushing yourself with your workouts, so you're not creating like all this fatigue and like damage to the muscle tissue, but you're just like not putting on muscle tissue. Like you look the same day in and day out, year in and year out. You're not actually building muscle tissue. I think that's a perfect example. Another example is like, okay, say you're putting on maybe a little bit of muscle tissue, but like your organ systems are starting to like struggle, that like you're starting to get like constipation and like swinging between constipation and diarrhea. So that would be another example, because like maybe you're getting the nitrogen from the organ tissues. Those would be like the big ones that I would see.
Okay, I think this is an important time for this question. So, Kathleen, it doesn't make any sense. Why eating a high protein diet, why would that lead to a net loss of protein in the body? Why is that happening? That doesn't make any sense.
So I think that I don't have like an actual answer. This is conjecture. I think that it has to do with you're dealing with the excess nitrogen in the body. And again, that nitrogen is going to ammonia, and the body does not like build up of ammonia. So it's like, we got to get this out as quickly as possible because we have too much here. So that would be what I believe is happening. Because like say like you're using a lot of that protein for gluconeogenesis. So like you'll see your ALT higher, for example. You may not actually see it higher though, because a lot of people don't have sufficient zinc, B2 and B6. And so their ALT is actually suppressed, even though it should be a lot higher than it actually is. And even though they probably have liver problems. But so you're like doing gluconeogenesis to make glucose, and then you've got to get rid of those nitrogen sources. And so then you see the nitrogen come out.
Yeah. And so essentially, like we were saying, it would be really nice for someone to track their nitrogen balance as they are changing their macronutrient composition. And I'm sure that they would see, similar to what they saw in the Minnesota Starvation Experiment, you have to have sufficient carbohydrates to maintain a positive nitrogen balance. We all want a positive nitrogen balance because it allows us to ensure that we aren't losing tissue. When you have a negative nitrogen balance, that means that you are losing more tissue than you are depositing. And you kind of see this like rabbit starvation state with a lot of people who are high protein, low carb for a very long time. You can see changes in their face. You can see changes in their shoulder muscles.
They're so lean.
Yes.
But it starts to look like they're breaking down a little bit more than building.
Well, and we've talked about this, and I, I'm not here to like talk about other people's bodies and stuff, because like obviously people like what they like, and they're trying to do the best they can, all that stuff. But at the same time, like you see the situation where people think that someone is jacked and they have a lot of muscle, but it's because they are so lean that like if you get a different camera angle, you see how tiny the actual circumference of like the arm is or the leg is, for example, and then you're like, oh. They're actually not as like muscular as I thought they were. It's just they look like they are because they have such little body fat around that muscle, and in between the muscle, etc.
It's like when you see like the really like skinny guy who's got like no muscle on his limbs, but he's got a 6-pack of abs.
Right.
But it's because that's it. Like you see all that because there's nothing else.
There's a difference between someone. So like, again, it's just the sheer amount of muscle in your base frame. We want to see that stay maintained or go positive, but if someone were to just lose a bunch of weight and they look lean, there's no telltale sign that they're gaining muscle.
Right.
It's just that it's showing. You can see the muscle, but
Exactly.
doing nitrogen balance testing could be a way to assess, or I guess getting like scans done, like DEXA scans and stuff like that.
Yeah, and I also think so. I mean, we can just talk about the FFMI calculator really fast. So FFMI is your fat-free mass index, and it's basically like it's more accurate the less body fat percentage you have, but it is a pretty good tool to say, how much fat do I actually have to lose compared to how much muscle do I actually need to gain. And I think a lot of people would be surprised if they put their information in here and they
Where do
realize
they
that,
find
like,
this?
well, I'll send you guys the link and it'll be
Okay.
underneath the show notes.
Okay.
Yeah.
Description. Yep.
Yeah. I think a lot of people would be surprised to say, like, oh, I really didn't have as much fat as I think I needed to lose. I really need to gain a lot more muscle.
Yeah. When you sent this to me, I was just blown away because
Yeah.
like we're all always thinking like, oh, I need to lose more fat,
Right.
but we're never thinking about how much advantage it would be to put on more muscle first,
Exactly.
possibly.
Right. Yeah. And it is hard to put on muscle, especially when you're not like on an anabolic. It takes once you're through those newbie gains, it takes a long time to put on muscle. And so this is again like to me, this is another argument of like the kind of long, slow building in your maintenance to those max, as high as possible maintenance calories, and then staying there for as long as possible. Because again, anecdotally, I continue to find that the longer people stay at a certain calorie, that actually becomes their maintenance calorie mark. And so then if you decide to cut from there, you're truly cutting from that point versus like you're truly cutting from somewhere down here, if that makes sense. Like, so there's like a threshold effect basically. And in order to put on muscle, you have to be in an anabolic territory. You cannot be in a catabolic territory. And so, that doesn't mean that I think people need to bulk, maybe a very slight bulk, but I think staying at maintenance and just this very slow recomp, which will take years, it will take years. I'm going to say that. But again, it's this slow recomp in a way that's in an anabolic way, supportive to your body. And when I say anabolic, you will always have periods of catabolism because the body is always cycling between, okay, cleanup, and, it has to do with like when you last ate, sleeping, all of that stuff. But it's a ratio of like we are more in the anabolic territory versus in the catabolic territory. So, yeah, I think everyone should use this and see what their numbers are, and you're probably going to be surprised by like how much muscle you probably really need to put on compared to how much fat you need to lose. And again, I'm not saying that people don't need to lose fat because people will misquote us all the time. That's not what I'm saying. I'm just saying you probably have a lot more muscle to put on than you think you do, and probably a lot less fat to lose than you think you do.
So, given the time, let's put a pause on going through the chapters and let's wrap up today's episode with what people can do. So, I think maybe my main takeaways from today's discussion is like metabolism is important because your rate of metabolism will impact how your body functions. Like that's just a fact, right?
Yeah.
There are a number of things that impact that, and one of which is purely the amount of food that you are consuming. And then also the macronutrients that you are consuming, because protein is important, but it is not an energy macronutrient. And you do need to eat animal protein is important. Like you should be including that in your diet, but the more is not merrier, right?
Exactly.
Like if you do want to nerd out about this, assessing your nitrogen balance, I guess could be a way for you to assess whether you're in an anabolic or catabolic state. So what, for someone listening and they want to improve their metabolism, what would you recommend their first thing that they should do?
Well, so people are asking like, how do I do the reverse, basically? That's a big question I keep getting because, after you work with people, you start to kind of get a gauge of like how their weight is responding, especially like water weight swings, and then how much you can increase calorie wise. But obviously, like not everyone can work with someone else, and there's just not enough time in the day and all that stuff. So, something that has worked for people is using the Carbon Diet Coach, and there's other diet coaches in too, but the only one that I've like talked to people about is the Carbon Diet Coach. I believe it's by Lane Norton, and he has a reverse diet option in there. And in the reverse, you want to put the selection to like, it'll ask you like how much weight are you okay with gaining per week or something like that. Put it as low as it'll go, like all the way down. So
Yeah.
you're gaining like nothing per week. And it will very slowly increase your calories over time. Now, this is if you're tracking, right? And obviously when you're tracking, if you're eating meals that are pretty similar to each other, that makes tracking a little bit easier, and it makes tracking a little bit more like less error, right? Because there's always going to be error in tracking, but when you start to like have a lot of meal divergence, that creates even more error. But it is still, I think, worth doing. But a lot of people don't want to track, and it brings up disordered eating patterns and all of that stuff for some people, and I completely respect that and understand that. So you can do other things like the plate method or the hand method, where you like you start to kind of figure out like how much am I eating per day, and then you like very slowly start to build from there, like increasing the size of your fist basically per meal. That's another way to kind of slowly reverse. A lot of it's so nuanced, right? Because it depends on the person. Like a lot of people, if they're weighing themselves every day, that starts to create like disordered behaviors and stuff too. And so like maybe pictures work a little bit better for someone, or like measurements work a little bit better for someone. So it really depends on like what the person we're talking to is. But like if you don't even know like your starting point and you want to start tracking, what I would recommend for everyone is just for the next week to 2 weeks, just start tracking in Chronometer. Don't change anything. Just start tracking in Chronometer what you eat every single day. Start to see like, okay, what are the macro ratios that I'm eating? What are the micronutrients that I'm, not getting enough of maybe? And then also weighing yourself like every day, every other day. Again, the weight is just a number because again, we know how much the weight is fluctuating because of water, especially. And then you start to see like, okay, am I at maintenance, or am I in a deficit, or am I in a bulk? And then you can slowly start to adjust things from there. But yeah, so working with someone who respects this approach, I think can be great. I think.
Wait, pause. Exciting. Kathleen is going to be taking one-on-one clients here very soon. And so you can find a link to the wait list. It's going to be bopping, but link to the wait list in the description below to work one-on-one with Kathleen.
With a training and nutrition focus.
Yes, with exercise and nutrition, because I think something that's maybe clear, hopefully to the audience, is like maintaining muscle mass is like one of the best things that we can do for our health.
Yeah, maintaining and building for sure.
Yeah.
The focus is definitely going to be on hypertrophy. Because I think it's a little bit, I think what we're discussing is a little bit easier to convince people of under the guise of hypertrophy versus, like health recovery and stuff like that. So, especially when everyone in health recovery is saying eat less.
Or restrict.
Yeah.
Which just leads to eating less.
Yeah.
Yeah. So I think the Carbon Diet Coach, plate method, hand method.
The Carbon Diet Coach is an app. Yes.
What's that?
It's an app, right?
Yeah.
Okay.
Yeah.
Well, I think basically kind of what you're saying is like, you listener, audience member, you need to assess if you are regularly fueling yourself enough calories. And you may see like changes in your eating patterns, like Monday through Friday, like you may be like chronically under eating, and then you go through binge patterns in the weekend. Well, like that's not a healthy pattern. That's not going to lead to health. And so making sure that you are eating enough and kind of assessing what macronutrients you are consuming, establishing your baseline is going to be the most important thing. And
even for that, like the major reason people binge is because they regularly don't eat enough food.
Yeah, exactly.
Yeah, it's important for that.
So many people don't eat all day long, and then they come home at night and they're like, I'm freaking hungry. And you just eat, everything. And no judgment there. I mean, I was there at one point too when I was trying all these like fasting protocols and stuff too. But like usually when we eat, we're not necessarily eating like steak and potatoes, like a lot of people are like, I just want that quick, whatever you have. And then that leads to worse things, in my opinion, because they're not really like nutrient dense foods, or like maybe even if they are fortified, like food fortification, like the form, the absorption pathway, the dose, like there's so many issues there too. So Um, yeah.
And
But
I
yeah,
think
okay.
this practice, this homework assignment of like assessing where you're at, I think this used to just be like the standard thing. I think back in the early 1900s, people were better at taking care of themselves.
Right.
They were better at being more mindful of how they were feeling.
I think there was a lot less external influence too.
Yes.
That pushed people to these restrictive diets or even different ideas for their body and what that looks like.
Yeah.
And like fast-paced living versus like more like home-cooked meals and eating more regularly. There weren't as many distractions as well, which just makes it a little bit more challenging. I still think that it's okay to pursue hard things and have cool goals and push yourself, but you've got to be taking care of yourself with nutrition as well in parallel.
Yeah. They even talk about in the basal chapter that like no one was sitting here like accounting for what they were eating. They were just like eating, and then from what they were eating, that's how they calculated like how many calories and macros and stuff that they were getting. So, I think it's important that as you start to track your food, that you also start to track like satiety signals if you have them, hunger signals if you have them. Like look for them. Don't like catastrophize yourself and like don't become too mind body where you're like, oh my goodness, what was that? But like start to look for those things and start to look for like, okay, when I eat these foods, I feel this way. I feel when I eat these foods, I don't feel as good. Like this, for women, like the time of my month, I feel like I need more fats. This time of my month, I need a little bit more carbohydrates. And so like realizing that we are dynamic people, things change, seasons change, all of that stuff. So you kind of rebuild that relationship, that intuition with yourself. And like what Sarah said, and I think we talked about this last time too, like I know a lot of people started these things out of like the best of intentions. They're like, I have this health issue, or I want to get stronger, I want to lose fat mass, whatever. And so you like go to the first influencer that kind of like clicks with you and you do what they do, but then like that doesn't start to work anymore. And then so you keep jumping around and then you end up in this state. And I think we said this last time, but like it's almost like, I'm sorry you're in this state and it's going to take some time for you to dig yourself out of it, but you can do it.
Yeah.
I think it's a very positive thing of like, you can do it. It will take some time. You will need to support yourself. The mindset, like if you're having mindset issues, especially when it comes to that water weight gain that we know happens and it stays for a long time, like we saw that curve and everything, like, if you're having a really hard time with that mindset, like whatever you need to do to work on the kind of more psycho-emotional side, body image side, like all of that stuff, I think that's very important as well,
Yeah.
I want to just add that we're not advocating for people to gain a bunch of weight, and we're not saying that fat loss is bad.
Yeah.
Because I feel like that gets lost in the messaging a lot. So you just
Well-
kind of have to earn the right to go into the deficit if you want it to be sustainable.
Well, and that's why I keep like trying to emphasize we're at maintenance calories. And people are like, but how can I increase my calories if I'm at maintenance? It's because maintenance is a range, and it's a pretty big range, like my maintenance was like 1,700 to like 3,000, like it's a long range. I can put myself back at 1,700 if I really wanted to, but I don't want to be there because I don't like being there. I don't feel good being there, but I can maintain my weight there. Right now I would lose weight though, because like 2,800 has become my norm for a long time, but like over time I could put myself back there if I wanted to. And I am all for doing a get in, get out cut, like when it's time. But the problem is I just don't think that people spend enough time reversing, staying at maintenance for a while, making sure that maintenance calorie is actually their maintenance calories now.
Yeah.
And you hit this like threshold effect. And then cutting from there. I think that's great. I'm all for that.
Because what we saw from the Minnesota Starvation Experiment is like they initially lost a ton of weight going low calorie, but then the body adjusted because that's just the body likes homeostasis. So the metabolism down regulated. And so they stopped losing weight at low calorie. And so that's what's going to happen to people if you're chronically under eating. That's going to become your new maintenance.
Exactly.
And chronically staying there is not a good idea. So like Kathleen just said, in and out. You got to get in that fat loss phase, out. And
the out is the reverse.
Yes. Yeah.
That she's talking about.
Yeah. Okay.
Yeah, and so like, schedule it. Like this is the most important thing for the next 6 to 8 weeks, like, and recognize that life changes, stresses pop up. And if you need to come out of your cut because something in your life changes, that's okay. Like, you can always go back to a cut again. I don't think it's good for people to white knuckle cuts and stuff like that, because the body starts to rebel against you, you know?
Yeah.
So
In a future podcast episode, we'll talk about Sarah's cut that Kathleen helped her go through. And how many weeks was it?
It ended up being what, like 7 or 8?
7. Yeah, it's like
7.
between 7. It's like 7.5, basically.
7.5.
Like, people need to really like let that soak in. Just 7 to 8 weeks and then reversed out.
Yeah, and at like 7, at like week 7, I was white knuckling, so I had to leave it.
And
so
Yeah.
What people don't talk about is the months, years before that of reestablishing maintenance calories and building a solid metabolism before that.
Well, I have a timeline for my wedding, so I could have gone longer and I should have gone longer, but we had a
Yeah.
life happens.
Yeah, and I completely understand that, you know, goals happen and stuff, and that some people will choose to go into a cut even if it's maybe not the best thing for them at the time, because they are making a conscious decision that, yes, this may not be the best thing for me. Yes, it might, you know, pop up more symptoms, all of that stuff, but I have this goal and I'm consciously choosing to do a get in, get out cut for my goal. And then, you know, down the road, I will deal with things. So, you know, I think that's the most important thing, is like taking ownership. Like, yeah, like, there are ramifications for what you do. And sometimes that's okay. Sometimes the cost benefit, you choose it, and that's great. And I'm all for that. But, you know, I also do think like for me, if someone comes to me and they're like, I want to cut, and they're at 1,500 calories, I'm going to be like, I'm not the person that you want to work with, because I'm not going to cut you from 1,500 calories, you know? And if I lose clients, like, I'm all good with that, because to me, that's dangerous. You know?
You would have to cut it like 900 calories. Oh my gosh, that would be so horrible.
There are people who eat that much.
Oh,
daily.
that's so sad.
Like
Yeah.
the HCG diets and stuff like that too.
It's
Yeah.
just the
Yeah.
OMADs, everything.
Yeah.
So
Okay. All right.
yeah. So do the FFMI. Take stock
Yes.
of your, you know, are you in maintenance? Are you in a slight bulk? Are you in a slight cut? And, you know, slowly start to adjust from there. If you want something that kind of helps you as a guide, I would look into the Carbon Diet Coach. Again, set that as low as possible. And you know, if you're like really concerned, you can always, like, say it tells you to increase by 25 calories this week, only increase by 15, for example. You know,
Yeah.
so like, you can do this as slow as you need to.
Yeah.
Because
Yeah.
I do not think putting on a lot of fat mass is the answer either, unless you need it, right? Like, depending on the population. Like, if you're coming from, you know, like a disordered eating disorder,
Anorexic style. Yeah.
like, and you truly need to put on some fat mass, like, then you definitely should. And I hope you are working with a healthcare team that is like helping you through that and stuff. Like, we're not the people to work with you, you know?
Yeah.
So, but yeah, I don't think for, you know, a average body fat percentage individual, putting on fat mass is the way to go.
Yeah.
Like I said, unless you need it.
I think that like a good goal for someone would be to like work up to maybe close to at least 2,400, 2,500 calories for your maintenance and maintain your weight there. If you're able to do that, like, that's awesome.
Yeah.
And slowly work your way up. It's like, again, the mindset that we've shifted away from is like, the more we can eat and maintain our weight, the better. And that's just going to lead to more function in the body.
Right. And again, I just want to highlight 25 to like 3,500 was the norm. We're talking about the norm. We're not talking about some crazy outlandish thing. We're talking about this was the norm until like relatively recently. And, you know, I just will highlight again too, like, the last kind of like 2 generations or so are really like the first generations, at least in the history that I know, that have purposely decided to cut their calories. And I just wonder about the, you know, we see these explosions in health issues. And I really just wonder about it, you know? Again, red flag.
Autoimmune.
In health issues and eating disorders.
Yeah.
Exactly.
Autoimmune, Lyme, food intolerances, like all these things is it just a result of a loss of function from just chronically under eating?
I don't know.
Yeah.
I think a big part of it is probably, but especially because as you see people come out of the low energy availability state, a lot of these things clear up. But at the same time, I will leave room for the possibility that there are other environmental, et cetera, factors impacting this as well.
Glyphosate, microplastics, PUFAs. Yeah.
Yeah, but again, though, those to me are all impacting the energy metabolism. So if we
Yeah.
can help the energy metabolism, to me, those things will improve. Maybe they don't get back to 100%, but they should improve. That's my viewpoint.
Yep.
So.
Great. All right. Thanks, Kathleen. Next time we'll finish up more biochemistry and physiology. So stay tuned, everyone.